All right.
All right.
Thank you. All right. Good morning, everyone. So my name is Rui Abreu. I'm a software engineer at Meta, and I'm a member of a team that is looking into understanding developer productivity. And today I'm going to talk a bit about our efforts and how we try to empower developers in being more productive. So let me just start by giving you some context. This is one of out of the many triggers. I don't know if you have seen this, but we are in the year of efficiency at Meta, and Mark Zuckerberg has this press release earlier in the year. And if we look at the press release, we have seen down there that it talks about a couple of things that are related to developer productivity. For example, it says that there are several work streams to improve efficiency in order to dramatically increase developer productivity. So this is, of course, one of out of the many triggers. There are many others, such as our culture at Meta, which is the hacker way. So let's try to decode a bit the title. So the title was moving fast while delivering high quality code. And then I'm going to try to make the bridge into productivity, so that to make sense of why this talk is interesting here in this context, right? So on the one hand, we want developers to move fast. Moving fast is not always a good thing, right? I mean, you can drive fast from place A to place B, but if you go too fast, you may have accidents, and then you don't reach the end goal. So you need also to take into account high quality, right? The health of your code base is extremely important. And so if we put these two things together, then we end up with this notion of productivity, right? And that's the things that I will talk about in the next couple of slides is productivity in perspective of making developers or empowering developers to move fast while maintaining a healthy code base. Now, having set the context, let me just share with you the agenda for this talk. So I will start by this notion of measuring productivity. Then I will go into some of the drivers that we are looking at this moment. And then some words about the next steps, what we think would be nice to explore in the next couple of weeks, months. And finally, there will be time, as you know, for Q&A. Oops. The first question when we talk about productivity is how can we measure productivity, right? Well, there are multiple dimensions, multiple things that we can do to measure productivity. And before you know, if you try to measure all those things, we will get overwhelmed with metrics, with plots, with graphs, and nobody will be able to make sense out of it, right? Besides, some of these things are pretty objective and are easy to actually track and measure. On the other hand, there are things that are a bit more subjective and difficult to track, right? So, for example, if I take a look at those many things over there, I'm pretty sure that we'll be able to add many more. Like burnout, it's not pretty easy to do. I mean, there are ways to do with wearables and whatnot, but it's not something that is easy to do. And I'm also pretty sure that if I would come up with a project saying that Meta developers from now on will have to use wearables and I will be tracking their vital signs and whatnot, there will be huge pushbacks, right? And so we don't want to do that. But anyways, it would be possible. But it's a bit also subjective, right? I mean, maybe someone under high stress conditions will produce perfect code, but maybe some other people will not do that. So basically what I'm trying to say is that measuring productivity is difficult, and actually what works for one team may not work for another team, right? So you also need to put that in perspective. Now, metrics are actually kind of dangerous, right? And then it comes also into question: what should we measure for a given context, a given domain, right? As an example, suppose that we have a tool in your IDE that is able to come up with a definition of a function if you over a function usage, and we can measure the latency of this pop-up to happen. You can measure a bunch of things, but then if we don't measure the right things, then even if this gives us the wrong function, then we'll say that this is actually perfect. Suppose that you are just measuring latency of this tool, right? one or the other, the latency will be exactly the same, but the one on your right hand side is actually completely wrong. So it's not good for developer productivity, right? Anyways, so again, this is to make the case that measuring productivity is difficult. Now, as I guess most of you know, there are efforts and frameworks to help companies measuring developer productivity. I'm not going to go into the details. This is just to give you some context and background. But one of the frameworks is the DORA framework, which measures productivity in those four pillars or metrics, if you will. So the DORA framework takes into account on the one hand velocity, and then on the other hand stability of the code, right? Quality of the code. Then another pretty famous framework is the SPACE framework. So the SPACE framework was an effort that came after DORA, and the idea, or let's say the criticism back at the time, was that DORA wouldn't capture everything that was important to measure developer productivity, and so they came up with another framework, and this was back at Microsoft and a couple of other folks on GitHub and Microsoft both came up with this framework that actually takes into account a bunch of more dimensions and tries to capture productivity, amongst all those dimensions. Now, because everybody talks about it these days, I think I also need to have a slide about this. So McKinsey, like 2 weeks ago or something like that, came up with a new framework to measure productivity. There were some kind of pushbacks in those in that blog post from Gergely and Kent Beck and a bunch of other folks. If you haven't seen it and you want to see the blog posts, you can have access to the blog post in that QR code. But essentially, they go about and they say, well, DORA and SPACE, they don't track everything, and so they came up with 5 new dimensions to track productivity. Then, of course, there are some criticisms over there in that blog post. Then the link for the blog post is in that QR code. Let's not go into the details and because this is a bit controversial at this point. But anyways, that's yet another framework, right? Now, one of the things about the SPACE framework is that those 5 pillars, they do not suggest which metrics to track. They sort of say, well, there are some metrics that are interesting under each of these pillars, but they do not tell you exactly what to track, right? Another thing about the SPACE framework is that it's just too many metrics, right? You end up with many metrics, and then if you have too many metrics, then the whole thing becomes complicated. So we decided to look at that, and starting from the SPACE framework and the DORA framework as an inspiration, and look at which metrics we care at this point now that will help developers be more productive, right? And we came up with we ended up with these three dimensions. One is velocity, another one is reliability, and another one which it's a bit more difficult, and I will go into details about that, is readability. And the cool thing about these 3 metrics is that one way or another, they have some tension between them, meaning that if you optimize for, let's say, velocity, then you'll have to compromise one of the others, right? And so by having this tension between the metrics, then the good thing is that it becomes difficult to game, right? One thing about metrics, and all metrics are one way or another gameable, right, is that you need to find a couple of metrics that make sense, that if you game one metric, then you are actually compromising the other metric, right? And the idea of these 3 metrics is that, it makes the whole thing less gameable as a whole, right? Of course, we don't know where the sweet spot is. That depends also per team and whatnot. But the idea is that, right? That we can track a couple of metrics, and that, again, it won't be that easy to gauge, right? So this is kind of our approach, and that's what I will go into the detail next, right? So next, I will take a look at the different, let's say, drivers. Each of those vertices are the drivers, and I will start with authoring velocity. Then I will discuss reliability, and then I will discuss the readability slash knowledge. Okay. So let's start. And before we go into the drivers actually themselves, let's me just give yet another context, right? So we are tracking developer productivity. Now we need to understand what developers do. So these are the set of tasks that developers might do, right? And this is where we want to see whether developers are being productive in performing those tasks. And there are a couple of things that a developer will do, such as, splitting mega classes, implementing new features, fixing bugs, upgrading tooling, you name it. There are a bunch of things that you can imagine, right? Now, when you have developers doing all these things, then the question that we want to actually answer in terms of authoring velocity is, how do we measure how easy it is to author code, right? And actually, this is not about the velocity, right? If your code is a big mess, then of course velocity will in principle be way slower than if your code is is clean and it's easy to implement new things, right? And so we want actually to measure, and those three metrics are actually helping us in measuring how easy it is to author code, right? Also, for you to understand, this is also a contextual slide for you to understand the reminder of the presentation. So authoring code at Meta, the workflow is as follows. So you start authoring code, you implement something, and then when you are ready, then you can publish what we call a diff, right? A pull request, a code change. And then we use a tool, an open source tool that's called Fabricator. And Fabricator is like, this is a slide that shows Fabricator. Of course, it's blurred here and there. But essentially, what you have is the pretty common fields in such a tool, which is you have the code changes themselves. You have a summary. You have the reviewers. Then the reviewers can engage with the authors, can make change requests, can accept the diff, can do a bunch of things. Perhaps something that is slightly different from most tools is that at Meta or in Fabricator, we use something that's called test plans. A test plan is not meant to be exhaustive testing in any way, shape, or form. Is more a way for the author of those changes to communicate to reviewers how they can test the changes, right? So typically it's a set of bullet points that says, if you run this command, then you should get that. If you run this other command, then you should get another thing. And people there put all sorts of stuff, right? They put, screenshots of what you expect to see. For example, let's say that I'm changing Facebook for the logo not to be blue anymore, but to be, dark, black or something like that, right? So you could just say, okay, if you run this diff in your system, in your computer, then this is what you should see in your Facebook page, right? Basically, I'm spending some time about the test plans because I will go into some work that we are doing now to empower productivity, right? Okay, back to the drivers, right? Enough context. So the drivers, the first one is authoring velocity. Now, how can we actually capture velocity, right? So keep in mind how we author code at Meta, right? That's why I spent some time in that slide. Now, authoring velocity is actually our attempt to answer that question, right? So it's trying to capture how many hours does it take for a developer to write and land the diff, right? And so there are a couple of things that the developer needs to do. And so this authoring velocity concept captures the active time, the developer active time while authoring that code, right? So essentially, you start writing on a particular change, on a diff, then you publish the diff, then you may take a break for lunch, or you go for for the weekend or whatever it is. So if you are not working, then we don't take that as part of the authoring velocity, right? If you are actually active in your computer, then we take that part of your author velocity, right? And so this is actually will give us the notion of author velocity per pull request, per diff, right? Now, there are many things where you spend your time while authoring code, right? I mean, Hans just talked about the impact of tooling. Actually, one of the tools that we use to build stuff is our own Buck tool system. For those of you that do not know Buck, it's an open source build system developed at Meta. It's kind of similar to Bazel, Google's Bazel. Anyways, enough, because this is the Gradle conference, right? So don't want to I don't want to make you switch to Buck 2. But anyways, one cool thing about that is, well, there was some revamp of the tool set, of the tool chain, and actually the tool chain is twice as fast, right? And by doing that, and there will be a talk by Adam later today, I think, about Buck, and I think it will go into details about those kind of things. But anyways, by doing that, then this will have a positive impact on authoring velocity, right? Because there are some times that you have to wait for you to test and to build, that now is is twice as less, right? That's basically the impact of that. So, you know, in author velocity, you have the time it takes for a bunch of things, right? You authoring the code, you typing things, but also the impact of tooling, right? If you want to know more about about Buck 2, then that's the QR code. Now, another example of the impact of a tool in this authoring velocity is the Wasabi tool. Wasabi was launched like a year and a half ago, more or less. And Wasabi is a Python language server that helps you with a bunch of things, like, you know, linters, gives you code snippets, you know, all sorts of things that you can think of a Python language server. And, what we have done is we checked the impact of Wasabi again in author velocity, right? So what we have seen is that by taking the control group and the test group was using Wasabi, the control group was not using Wasabi. And now by using this tool set, people are faster in 20%, right? So that's, again, a positive impact of a tool, right? That people use, right? The QR code points you to the blog post that shows you more information and details about that. Of course, I'm happy to talk offline about these things. Okay, now I have talked about the impact of the tooling, but now let me talk about the impact of code complexity, or in other words, the health of your code base, or the health of your code base, right? What we have actually studied was that there were a couple of teams that decided to engage in an effort to reduce cyclomatic complexity, and so they started doing that. And now the next question, since we have this authoring velocity, is to know what is the impact of this reduction in author velocity. Are developers now faster or not because they have let's say a more healthy code, right? And I'm considering that, you know, less code complexity is healthier code, right? In this case. So those efforts led to a 60% reduction in complexity. And now if we take a look at the author velocity, and now you may note that the x-axis are different, right? I mean, it's slightly later because you need to wait some time before you observe the impact of the code reduction. I mean, it's not immediate, right? But what we have seen is that for that particular code base that was reduced 60% in cyclomatic complexity, now the author velocity is actually, or authoring velocity, there is a typo over there, that's authoring velocity, but anyways, then there is a 42% reduction. This means that, if teams engage in reducing cyclomatic complexity, then your code is healthier and it's easier for your developers to contribute, right? And it's actually a pretty good number, right? People are almost, 50% faster in authoring code now, right? And this is the cool thing again, is that showing the two metrics side by side are important in a dashboard, because you can see the impact of one in the other, right? All right, enough about authoring velocity. Now let me move to reliability. Reliability also has a proxy for quality, right? There are a couple of things that we are trying, and one of the things is, using something that we call diffbird. If you don't know what it is, actually there is, again, the QR codes if you want to know more. There is a lot of links for you to study at home. I guess those are the perks of me being a professor, or, I used to be a professor in another world, so I'm give you more and more materials to study. Anyways, back to to the slides. So what we did was we put into play one of these, let's say, large language models, right? I mean, they are cool these days, and we tried to extract information from Fabricator, from this pull request information, to try to capture diff intent. And I will say in a second why we think diff intent is interesting. Now, diff intent can be categorized in multiple things. For example, implementing a new feature, bug fixing, doing some privacy stuff, you name it, on call, and that sort of things. And now, when you categorize those diffs, then it will unlock loads of opportunities, right? So we have authoring time now for per diff, as we used to have, but now also per diff or per intent, right? So as an example, suppose that we have three diffs. These three diffs over here. Each diff touches different files. Now we measure authoring velocity for these diffs. Like the first diff took 3 hours for the authors to land. The second diff, 9 hours for the authors to land. And the third diff, 3 hours to land. Actually, you could do interesting things as well, but I'm not going into the details of that, which is you could try to split based on the churn of the files. You could try to guess how much time you are spending in each particular file, right? But let's not go into that because there is no time to talk about everything anyways. And so now when we do diff intent, right? And the question might be, why do you need an LLM? Why don't you ask your developers to do that? Well, developers are sort of lazy, and they don't, sorry about that, guys. And they don't put the tags or the proper tags, or they mistag stuff, all sorts of things. And now if you have LLMs, well, maybe we can get a proper label, right? And so if you as a developer you give us the label, then we don't need the LLM. But if you don't give us the label because you forgot, then we can always come up with a label, right? And so if I come up with these labels either manually or using an LLM, then I can start doing things like, okay, the authoring velocity of fixing bugs on file B was 6 hours because it's the average in those two diffs, and on file A is 3 hours because it was only involved in that diff 1. And so you can start coming up with that information and show that to the users, right? And then when you show this, you start to know that, well, whenever I need to fix a bug, if file B is involved, then this will take quite some time. So you may want to consider to refactor or to do something with that file, right? Well, we can also count, of course, how many files are involved in bug fixes, and those will be files again that would be interesting to surface to users as files that are sort of problematic, right? I mean, if after a year you find out that every time you fix a SEB, this file was involved, right? Well, either you change the file or you fire the developer that is working on that file, right? I'm joking, of course, but you get the point, right? If you find out that particular file is very problematic, has high CCN complexity, it's very difficult to author code there because you are always very slow, then you need to do something about it, right? That's the main idea of these metrics, right? All right, so another work that we did, and this is actually an academic paper. That QR code is no longer a blog post. Now is an academic paper that we published last year about trying to explore the quality of test plans. Now, as I have shown you, there is this field with test quality. As you can imagine, developers do all sorts of things, right? It's open text. Sometimes they say NA, right? Well, say again? YOLO, all sorts of interesting things, and well, we wanted to measure whether there was some sort of correlation between test plan quality and reliability, right? And the reliability in the sense of whether that diff would lead to a a major problem, to a SEV, right? So again, what we decided to do was to use NLP-based approaches, right? Large language models again, and we tried to predict whether or not we could quantify quality of a test plan, right? If we could, then this would be information that we could show to the user, saying, "Hey, your test plan is not good enough, so consider changing it, right? Consider not just writing YOLO or not applicable, or I don't know, or just running the linter." There are many of those that you just run the linter and say, my changes are safe. I run the linter, there were 0 mistakes, right? Sure, yeah, I understand that. Doesn't mean much, right? Anyways, so these are like in a nutshell, like the summary of our findings. So what we have found was that high quality test plans, they actually help to improve quality and also engagement. So we measure engagement of reviewers and the authors as well, right? The cool thing about is that, well, NLP-based techniques are actually well suited. Why? Because test plan is free text, right? A test plan, okay, there are commands and whatnot, but it's free text. You write whatever you want there, right? And so that's very well suited for large language models, any NLP-based technique. And now the cool thing is that now with this test plan quality, we can use that to actually is useful to inform improvements in developer tools and experiences, right? Because now we can, for a team, we can say, hey, your test plans as a team, right, are not good enough, and therefore this is not helping developers. Developers are not engaging in reviewing and that sort of thing, right? Yeah, and just to finalize that work. So what we have seen is that pull requests with high test plans qualities are observed to first be involved in less outages, be reverted fewer times as well, and have more, as I said, reviewer engagement. And these, I think, are interesting things in terms of quality, right? And the reviewer engagement is good not just to review that particular diff, but also to spread knowledge, right? One of the things is that while you are reviewing, you are actually gaining knowledge about the changes, and that's actually good. Okay, another work. This one I don't have QR code yet because it's yet to appear. So if you are in the area, so this is a conference that will happen in San Francisco here in the first week of December. But we did this dead code removal, right? I mean, just to remind you, we are in the driver about quality, right? Now, if you work for a company like Meta, monorepo, where people are doing all sorts of stuff in that repo, sooner or later there will be dead code. There will be code that is no longer being used for some reason, but is still lying there, right? And that's not good, right? So essentially, what we have decided to do was to study the impact of removing that code, and the cool thing is that once you are removing that code, you are also removing data, and that's also important for privacy reasons and security reasons. We didn't measure that, but our hypothesis is that by removing that code, we are actually helping in getting a healthier code base, and therefore people will be able to author code faster, right? So that's the hypothesis, even though we haven't measured that in this paper. Anyways, I wanted to highlight this because it's this like state-of-the-art, pretty new research that is coming out of the team. All right, now let me move to the next driver, and this driver is about readability or knowledge spread, right? There are a couple of things here that are yet to be done. Actually, the model about code readability is something that is, I have been preaching about that, but it's difficult to do. So it's not something that we have done. But let's see if I can convince you to also get interested in such a topic, right? Now, one of the things in terms of knowledge spread that we did was, again, this is the same conference, different paper, as you can see. And this paper was, what we did was we tried to model developer centrality, right? So we wanted to understand how central a developer is for a particular file, right? And this is important to look at because it tells you a couple of things. So for example, if you have a developer that is central to a file, it means that he has a lot of knowledge about that file, and maybe he should be the person to review a diff that is complex, right? And so you can just ask that developer to look at the thing. So we studied developer centrality. We have observed a couple of interesting facts, such as tenure eventually plateaus, and we are not being able to go faster in terms of velocity. But also developer centrality doesn't change after 7+ years at a company, regardless of the project. So in the beginning, as you become more and more senior, you tend to touch different parts of the code, but then you settle in a part of the code, and you become the master of that code, right? Basically. Now, what can we do with that kind of information, as I was saying, right? So one of the things that we can do is, whenever we need to assign a reviewer, we can use developer centrality, right? So if I know that you are actually changing something in a particular part of the code, right? Then, and if that particular part is not trivial at all, right? So suppose that the intent is implementing a new feature, right? Then you may want to actually recommend as a reviewer someone that is actually very knowledgeable about that file, right? It also may work the other way around, right? Suppose that there are some reorgs, and now your team owns a file for which there is no central developer, right? So you own a file or some part of the code, and no one in the team has a clue of that thing, right? Every now and then there are some on-calls about that file, and nobody knows what to do, right? Because you own that just because, right? Or because someone left or whatever. And so what we can do with this centrality work, because we can show those numbers, right, in a dashboard, is to actually assign reviewers such that you spread knowledge, right? Such that you ask more people to be central to that file, to know about that file, right? And so that work was interesting because of those things. Of course, it empowers many of those downstream tasks, such as reviewers, recommendations, but also even just to show the centrality and the centrality health of your code base, of your team, right? Okay, so now this is the thing like that I keep dreaming about, and to be honest, I don't know yet how to do this thing. I say work in progress, but it's actually work not being done at all at the moment. Anyways, it's just something that I think would be interesting, right, to have, which is code readability, right? I mean, when you read a novel, you look at the novel, it's readable, so you can read it, and it's nice. You can understand the story and whatnot, right? I think we should come up with a measure for code readability, right? If I look at that code, and I don't think it's CCN, cyclomatic complexity, or those crazy metrics like maintainability indexes and whatnot, right? It has to be something different, right? And I think like with the advent of these large language models, maybe we are at the point that we can do such work. What is the main problem is to find a nice data set to actually train those models, right? Because we need a data set that says, okay, this piece of code is readable, that piece of code is not very readable, or sucks big time, right? I mean, I look at this code, what's this? So that's the thing, right? But now, if we will be able to do it, my hypothesis is that readable code will lead to less outages, right? And people will be faster, right? As a newcomer, right? And even when you onboard people, you can onboard people and ask to author code in places that are more readable, right? And I know that there are parts and there are algorithms that will have to be unreadable by definition, right? If you want them to be fast, but not everything, right? And so, again, I think that we should be able to do that as a community even, but I don't know yet, especially because of the data set, how can we get there, right? And again, this would be like my idea is like you take one of those large language models, you process everything, right? From titles, summaries, changes, even the engagement of the reviewers and whatnot, and then you say, well, this code is readable or not readable, right? And then you could show in a dashboard. And this, if we could do that, then the next step is, well, people can look at that and they can plan refactoring sessions for a code that is not readable, right? And that sort of stuff, right? There are many recommendations that we could do if we can get to that point, right? But again, this is me still dreaming out loud. We'll see whether we can get there sometime soon. Okay, so now moving to next. What's next, right? I mean, what we have in mind for the next couple of of things. Well, at this point, I was talking about the different drivers, right? And I gave some hints about recommendations. What can we do with those drivers? But I really think that what comes next are two things. One is these predictions. They need actually to empower downstream tasks with the recommendations, right? So, for example, the developer centrality, we can use that to actually recommend reviewers, know whether or not we need to spread knowledge across the team, right? And that sort of thing, right? And then another thing is to foster wide adoption of these metrics and these tools. I don't think creating new dashboards is enough, right? I mean, you create a dashboard, and developers are really annoyed because now I need to exit my IDE, and I need to check there if something changed in the author in the cyclomatic complexity or whatnot. I think those integrations and some of these recommendations, they need to happen where you author code, right? Being it in the Fabricator tool, in the IDE, you name it. But you shouldn't force developers to go back and forth and to context switch between the tools, right? And so I think these two things is what should come next. Of course, coming up with more metrics is also something that might be interesting. But my personal take on this is that we should not show too many metrics, right? Because if we show too many metrics, then it's the same as not showing any metric, right? Because people will not use anything. We just should show a couple of them that make sense to your team. Now, what makes sense to my team may not make sense to another team, and so these metrics they need to align with the things that you are doing, right? And that your team buys, right? If there is no buy-in for the team, then this is it. Then there is nothing much you can do. Yeah, basically that's it. So I still have 2 minutes, but anyways, I'm done, right? So there are now time for Q&A. I was told that people can queue up somewhere in some microphones. One is there and another one is over there. But yeah, time for questions. Thank you.